Good morning to those here in the United States. Good afternoon to our attendees from Europe, and good evening to those attending from Asia. First, I want to welcome back those that have joined us on the previous last two seminars on driveshafts and joints presented in late January and early March. By the way, if you missed any of these presentations, I'd like to inform you that we have recorded them and we'll be glad to provide them upon request. Today, we'll cover driveshafts and joints, main production process. And as you see, we'll have, towards the end, you will have a new session in which later we'll answer all the questions regarding all the previous sessions. Our goal through this presentation is to cover designing from the production process standpoint. Our session today will be led by Mr. Hans Bart Helms, who is part of the APA engineering group as a partner of ours. And I'd like to first give you a little bit of information on APA. Next slide, please. Thank you. APA Engineering has over 20 years of experience in helping several OEMs and Tier 1 companies by providing world-class design, computer-aided engineering designs services. Today, we have a strong presence in Europe and in the United States. Our efforts rely on a fantastic team of over 300 employees who are dedicated to over 350 customers. APA Engineering is ISO 9001 certified. It is also ISO 27001 and TIXAX Trusted Information Security Assessment Exchange, certified to meet BMW's requirement and its suppliers. Next slide, please. Thank you. Mr. Hans Bart Helms has many talents. He has over 45 years of extensive experience in the industrial engineering, manufacturing, and management for European automotive industry. And in the last 15 years, he has been successfully consulting with many companies. He has spent most of his career with JKN Axle Group. I also would like to point out that he has a new book, Manufacturing Technology for Merchants, that will be available for those that request, as well as the Guide Industrial Engineering for Market to Product. Hans, it's my pleasure to welcome you to the seminar, to the webinar. I'd like for you to take over, please.
Yes, thank you, Panico. Welcome to all our participants. And let's start first with the first and second webinar with a short review. By the first, we talk about the market, about the different kinds of joints, drive shafts, prop shafts, rear and front wheel driven cars, and plunge joints and fixed joints who are inside all of that car. In the second session, we discussed over movement in the car, over design rules, and how to calculate the capacity of the joints. And you see it will work here. And as you have seen here, it will work now. Okay, sorry, yes. The tripods are running in and out and bend, and the fixed joints are bending in a higher bending angle. This was the main of the first and the second session. But now let's talk about the third second, about some parts and joints and the different production, but we have only time to discuss over main production. Yes, We have we have seen the total drive shaft with outer race, with cage, with inner race, with 6 balls, and with interconnecting shafts. And I would like to show you something about production of outer race, of cage, of inner race, and interconnecting shafts. And in the end, a little bit over assembly. First of all, I have to show you something about the main quality control to see the tracks and what happens with the tracks. You can see it here. You have in the production and in quality control to check all the tracks, the track diameter that is very important for function and for lifetime of the joints. You have 2 balls, you check the PCD, and in the ball you turn around and check also the contact angle of every track, because lifetime, I mentioned it before, is very important, and although you check the outer diameter. The same you do by the inner race on the same machine, you can do it. It's very effective and efficient to do it in that way, and you can correct it directly. I have to switch out, sorry. But here you see what is also important before you make the design and you make the machine and the tooling, how to make a simulation of all tooling in the machine and what happens with the tool and what happens with the tracks. You can do it by simulation, and you have to do it before you start with this main project. Yes, so let's go on to the next, and we talk about outer race. Outer race is started with hot form blank. That's currently the efficient production rule, phase and centering. You turn off, you turn ID, and you mill tracks, phase and mill tracks soft, as you can see it here. You have seen the hot form blank, and here in the machine is loading and unloading with 2 spindles. You see, first you turn soft the ID, and in the same clamping, then you mill the tracks and make it here or prepare it for the induction hardening process will come a little bit later. Also, you see, you make here a small deburring. This is possible or necessary because of the chips. Let's go on with the process. With after drag soft milling, you have spline thread rolling. And you see splines by the long shaft spline and screws are done. And here by the short, you only have the spline in the short shaft. It's done by 2 racks, a typical cold forming process. But you must be careful here because you have some distortion after the soft or the hard forming process. Induction hardening is the next important main process. You see here one production in line. First, you make the induction hardening of the ID, of the tracks and ID, and in the second area, then you make the induction hardening in that line with the shaft side, with the outer ID, as you see it here. And yes, in a very short cycle time, because you can do both together. Next operation will be hard mill of tracks. As you can see here, hard milling now exists since nearly 20 years. Grinding is on the market nearly out. And you make here, as you can not directly see first, the hard turning of the cage size or the inner diameter, and then you make hard milling of each track. You can see it here a little bit better, and you can also, as mentioned, or just find the flying burning ships of the hard milling process. After this, you have powder coating. This was the last operation in principle. There are some washings between and some small operations, but here is the main operation flow and main, you see, soft milling, spline rolling, hardening, and hard milling. Let's go to the cage. Cage is tubeless, tube seamless form, as you can see it here in this main production. You have cut it long bars, and these bars will be now formed in a round. And after this round forming process, here you see the forming, and after the forming, then you come up to make the holes. The holes also formed between two rolls, and in the end you have the quality what you need. Similar like here for making cage in a high quality for the cars. Next is tube cut and face. Then you have the press form. Here only a small simulation of that. It was be done by AP engineering, and you can see how it will press. I make it very fast because of the time. You have it from the cylindrical, you press the ball form in a short cycle time with a normal press. Then you have here, you have then the ball form. After that, you have ID turn and face and OD turn and face. And here one example for turning with a vertical turning machine. You see clamped in the outer diameter, and also you see here a lot of chips. That's real and it's in work, and the chips are going out with one turn, and then the next operation can be started. After OD turning and ID turning, you have mill of 6 windows. Here you have main 2 processes. Here is an example to make a prototype by milling and by drilling and milling. But when you, in the end, make a calculation between 6 window punching, what's possible, you have a very short cycle time with drilling and milling. And when you calculate, you have in short example, a small advantage, sorry, for the milling process, and this will be done normally tray. Here is for the example for doing some prototypes. After that, case hardening, ID hard turning and OD hard turning, and mill of 6 windows. You also here see the hard turning process of the cage OD. was very critical, not so easy, because you have the windows here, and by windows you have cut in, cut out. And after this, in the background, you see the flying miller. And as you can see here in the cage, you make the ball contact surface in the tolerance what you need and what you need in the joint. Preparatory grinding is the last operation of the cage, and that's logical finish check. For inner race, you have merely some similar operations. Here an example, what you can see, it's loaded and unloaded by a robot, and soft milling of the inner race. Here an example of a cross groove, not of a fixed joint, and it's very quick to see the milling process. It's better than everything else, like hard forming, like cold forming, or yes, broaching is the next. You have three tools, and you broach the splines. Yes, that's easy. I say easy operation, but important is the quality of the tooling. And when you make 4, you have a good cycle time, and you are very efficient with the broaching of the inner race spline. Next is induction hardening. You have here induction hardening or case hardening. Both is possible, but example by a cross groove joint with high energy, you can see you have here an effect of this high energy, and sometimes double frequency you can use to make induction hardening of the inner race. Next operation is OD and mill hard turning. It's nearly the same operation in principle, or you have nearly the same machine like the outer race. You make OD hard turning, and after the hard turning, you have the hard milling, and here you can see better the flying chips and the typical noise for the hard milling. After hard milling, vibratory grinding, and that's all, but finish check, it's okay. So, yes, interconnecting shafts. Interconnecting shafts are principal in bar shafts, in welded shafts, or in hollow shafts. And you have a semi-finished production, you have a pre-production, a finished production, and a hardening production. Here you can make cells, and inside of the cells there are a lot of similar operations. By bar shaft you have the saw, by the welded IC shaft you have tube saw, because you use a tube cut to length by the stem, and then you have face and centering after welding or before welding for the stems. Tube saw, cut to length, and staging process is the basic by the semi-finished production of the hollow shaft. Face and centering then, and complete turn, face and centering, complete turn, face and centering, ends to turn here by the hollow shaft, also here ends to turn by the welding shaft, but there's no need to turn. Basic is the finish production, spline production, groove turn, deboring and wash, preserve, and powder coning. That's the same by all of these 3 different kinds of interconnecting shafts. Induction hardening, tempering, correct detection, straightening. Here is the same, but by hollow shaft, there is normally case hardening, or in some cases you can use induction hardening, but here you use currently a special design. To see the processes: cut, saw to length, place and centering, turn complete. By turning complete, you have principally two different machine or kind of machines. Very similar is horizontal turning machine with holding in the mid and totally with 4-axis turning. But you can do the same in a vertical machine as you see here. By a vertical machine, you have an advantage, smaller space. That's all, but also 4-axis holding and turning over the whole length in both types of machines. When we go on, we can spline rolling, axle forming, both sides. We have two different possibilities with spline rolling. You have here in spline, and on the other side you could have perhaps another spline number of tools or what you need in your design. This is one possibility. And here you have the axle forming process. It's done by simulation because in the machine you see nothing, and it's forming by a special tool of the spline. This is also possible. Next is hardening before tempering. Yes, in that case, we have a scanning process of hardening. You can also do it in one shot. Both is possible. Machines are very expensive. And you see all 4 bar shafts are hardened by scanning. And yes, this is the process what you can do. Sometimes it's absolute standard. In the end, you have a straightening, and by the straightening, you can do it by hand, and also, like you see it here, by automatically scanning, turning, look for the distortions, and then the machine is learning by themselves and very efficient. Powder coating is the last operation by the bar shaft. Main process of driveshaft assembly. You come from all these parts to the total driveshaft. You can do it in full automatically lines, like here also in a simulation, or in cells. Cells where the handling is done by robots or by workers. And you have a pre-assembly in principle where you make boots and caps together. You have to clamp with force control, sorry, and then circlips of IC shaft. IC shaft innervates with press in force control and press out control. When you take the bar shaft in the inner race spline, you have to control the force, and you have to make sure that press in is okay and not too big and not too small. It's a very critical process in the whole process of drive in the whole processing of the drive shaft. Boot assembly, some boots will handle over outer race and in the position. Crease will fill in, and small clamps in the end are closed, also with closing force for the clamps. Signing with label and packaging. Yes, that was all then in a very short time. I think about 20 minutes. The total drive shaft was produced and assembled. You can see it is very quick. One at last, you have here a typical fixed joint. You need a special tool to assemble the ball in the joint. First you make inner racing cage, then this totally in outer race, and after that these 6 balls are going in the tracks. And what's very important, you have an assembly check here around table example. When we see this assembled joint goes on this round table, first the check the 6 balls. It's very important. After this, you have an extra clearance to control for lifetime hold and for function. And after this, you have a dynamic bending torque. First, you make one movement, you turn and you bend. And after this, it will measure by turning the bending, and you have here a min and a max in that dynamic bending torque. Grease will fill in at last in the joint, and then the joint will handle over to the line. That's what I mentioned before. That's all. Thank you. There are some more questions, and I handle back to Panico. Hello?
So I'm sorry, I was muted, Hans. Sorry about that.
So it's okay.
For the button, each one of these platforms, the button is in a different place for you to unmute yourself.
Yeah.
Well, thank you again for a great presentation, and invite our attendees that joined us over here to ask any questions through the emails that were posted on the chat. And I also would like to tell our attendees that the next session is going to be covering the last 3 sessions together, and like an overview, and also will give you the opportunity to ask questions on any of the 4 sessions at that point in time. Lastly, APA Engineering will sponsor those that are interested with a copy of Mr. Barthelm's books that are in German. I want to make sure that you do know that the books are in German, but APA will gladly sponsor that for those that are interested. Again, if you have any questions, please do not hesitate to reach Mr. Barthelms or Swami per the emails that you can see on your screen right now. I want to thank everyone, and Hans, wonderful work. Really appreciate what you've done on all 3 sessions, and look forward to the next one. July
Yes,
2021.
thank you. Yeah, in July we plan or we think about to make a short seminar about future and actual developments in joints, 10 balls, 12 balls, or small balls, high-speed joints, and we can discuss over cost calculations. When you want to let us know if it is interesting for you. And yes, I wish all a good time, and hand over back to Panico.
Thank you again, Hans, for the presentation. Thank you everyone that attended. Please take note of both emails at the end of this slide over there. We're open and interested in answering any questions that you may have, and we'll certainly look forward to seeing you again or talking to you again in July 2021. Thank you, everyone. Good night.